Graphs and functions and coordinate geometry. In this video, we will focus on the basic concepts of functions. You will find this on page 97 in the Namibian AS-Level Mathematics textbook, y equals mx plus c to success. The basic concepts of functions, relations and functions. In ordinary level mathematics, we learned that a function relates an input to an output. It is like a machine that has an input and an output. So it comes in. We are using the formula. This is manufactured inside, and then it throws out something. It performs one or more operations on the input. For example, the various values is taken in to produce an output, the result. The operations performed on the input is known as the rule or defining equation of the function. This is 2x plus 1. So I will take the value of x, I times it 2 and I plus 1. A function is such that each input produces only one output. The input x and the output y of a function can be written as an ordered pair, x, y, and a function can be represented using words, an equation, table, or a graph. The equation y equals 2x plus 1 is a function. It is useful to give a function a name. The most common name is f bracket in x. So we replace the y with the notation fx. So in the place of y, we put fx. Therefore, fx equals 2x plus 1. Instead of saying y equals 2x plus 1, we say fx equals 2x plus 1. This is read as f of x. It is very important to note that f of x is really nothing more than a fancy way of writing y. We can have other names, g of x, h of a of t. Okay, there is a few other names. So we don't, it's usually in one question. As soon as we want to bring in another function, we give it another name. A function is a special type of relation. In this set of ordered pairs, each x value has only one y value associated with it. In other words, if an x value is substituted into the equation will give you exactly one y value. Functions are a subclassification of relations, as illustrated in the diagram. If the graphs are given, you can do the vertical line test. In a function, any vertical line drawn through the graph will intersect it at only one point. In a relation, a vertical line drawn will intersect a graph at more than one point. Okay, so there's the relation, there's the different points, but this is the function. Okay, the reason why, if you see, I just want to see 1, 1. So if I substitute 1, it gives me two different values. That's why it's not a function. Okay, but here I can see every x value is just giving me one y. So functions is a smaller group in the group of relations. If I show you this graph and I explain it to you, this is now again the relation and this is the different kind of functions. This is a function, a vertical cut once, but this is cutting 2. That means, do you see this x value as I showed you there, but it's having two different y values? Then it's not a function, then it's a relation. Okay, and then it's same here. 1x, do you see? The x is having, okay, this x is having two different y values, but very important. Now, even I'm going to make it bigger so that you see it. I just want to read you the notes. Let's start with this one. -1, 1. So duplicates of y values, it is a function. So the y value can repeat. Do you see? So it's different x values, but the y value, then it's a function. But if I see for one x, I have the same y. Do you see this? If duplicates of x values, it is not a function. Okay. I think here it should just be 4 and -3. Okay, because that is 4 and 3. In this example was just, let's just get in red. This was indicating. So if duplicates of x values, it is not a function. If duplicates of y values, it is a function. Okay. Okay, let's go on. Let's look at an example. Which of the following graphs represent a function? Now, if I look at this, if I do the vertical line, it cuts 1. Oh. So this is a function. But this one, so you see basically this x value, say it's 1. It's having different y values, so it's not a function. This cuts 2 times, it's not a function. Which one of the following tables defines a function? So if I'm looking at this one, now remember, if there are duplicates of x values, it is not a function. For a function, there can only be duplicates of y values. So if I'm looking at this one, it's going to make it bigger. So I see the duplicates of the x values, so it's not a function. But if I see the duplicates of the y values, that will usually be if I have points like this. If I have to draw a graph, I just want to show you quickly. In terms of a graph, this one, instead of looking, instead of the dots being like this, the dots will just be like this. So 5, so it will be like this. So if you cut, it only cuts 1. So do you see it's duplicate of y values? So this is a function. But and I'm going to show it now, because sometimes I also have to concentrate myself. But if it was duplicates, do you see? It's the line is not so nice. Okay. Doesn't matter. So if I see it's the duplicates of this, because it cuts it more than once, then this is not. So this is a function, and this is basically what it's explaining there too. This is not a function. Okay, so no duplicates. So if I look at this one, there must just not be duplicates of the x values, so it's a function. But as soon as I see the duplicates of the x values, it's not a function. This is just to test, very, very, very basic. I'm going to make it smaller. I think you can do, this is so easy. So I think just to make sure you do number A. And as soon as you finish with A, you can do also B. And as soon as you finish with B, you can also do C. Again, stop the video. First try it yourself, and then you can continue the video. Let's go back. Okay, which of the following graphs represent a function? Now, again, I just take your ruler. This is my ruler, and it only cuts 1. Do you see that? So this is going to be a function. If I take a ruler, and if I take a ruler, let's first finish the ruler with my pen. So this is a function. But this is cutting 2 times, so it's not a function. Okay, let's do the next one. Which of the following tables defines a function? Now, remember what I said to you. There can be duplicates y values, but there must just not be duplicates of x values. So this is a duplicate of the y value. It's fine. It's going to be a function. In this case, it's duplicate of the x value, not a function. Which of the following defines a function? Okay, no, we have to, this was easy to see. As long as we don't see the duplicates of the x values, so it's fine, it's a function. Okay, I didn't write it nicely, let's just write it better. This is a function. Is there duplicate of the x? No. So it's also. Okay, and that is the introduction.